number 8. This is an interesting one. This is a really, really good one. So it's all factored in the numerator for me, so that's good. So I look for holes. Is there anything that I can cancel out? And the answer to that is no, so it's none. My roots, I have them at -2 and 3. And then my vertical asymptote, I have those at x equals -1 and x equals 2. Tangency and togetherness. So here I do have some, because in the numerator I have a factor that has an even exponent. So in the numerator it's tangency. So it's tangent at x equals -2. No togetherness though, because I don't have an even factored on the bottom. And then in my horizontal asymptote, sorry, let me go back up here. So it is top heavy because this is x cubed in the numerator and x squared. So since it's top heavy, it is none. That leaves it open to possibly having a slant asymptote. So in this case, I got to check this out. So it's nice that this is all factored for me, but I actually need it to not be factored. So once I multiply this out, this is going to give me, in the numerator, x minus 3 times, so this right here is going to become x squared plus 4x plus 4. And in the denominator, I'm going to get x squared minus 2x plus x minus 2. So then I need to continue and multiply this out right here. So I'm going to do this, let's see, I'm going to do it over here. So I have some space. I'm going to distribute that x first. This is going to give me x squared, no, it's going to give me x cubed when I distribute it, plus 4x squared plus 4x. Then I'm going to distribute that -3, so that will give me -3x squared minus 12x minus 12. So then when I put all that together, back over here in the numerator, that's going to give me x cubed plus x squared minus 8x minus 12. All over this right here, which is x squared minus x minus 2. All right, so since the numerator has a degree higher than the denominator, then I have to check for my slant asymptote, which means I need to divide. I cannot use synthetic division here because this is not a linear binomial. If all I had was x minus 2, I could, but this is x squared minus x minus 2. So I have to do long division. All right, so x squared minus x minus 2. Got to divide that into x cubed plus x squared minus 8x minus 12. All right, so x squared goes into x cubed, x times x squared is x cubed. X times negative x is negative x squared. X times a -2 is negative 2x. So then I have to change my signs. So this becomes 2x squared minus 6x minus 12. So then x squared goes into 2x squared positive 2 times. And then really, I don't care the rest of what happens because that's as far as I can get on that anyway, which means then that my slant asymptote is y equals x plus 2. And then my y-intercept, it's easiest to look at it in this form. I mean, I don't think, like if I had this and I didn't need to do the rest, I'd probably figure out my y-intercept from this. But since I have this is way easier because I just ignore all my x's and I get -12 over -2, which is a positive 6. So this gives me 0, 6. Okay, then, goodness, the board has a mind of its own sometimes. Not responding. Okay, here we go. So then I need to do my number line. So on my number line, I put my roots and my asymptotes. So -2, -1, 2, and 3. So again, I would go back to the factored version of this to be able to figure this out. I think that's much more useful. So if I plug in a -3, that first one's going to give me a negative. Then the second one's going to always be positive because it gets squared. This will be negative, and this would be negative. So overall, this is negative. Then between here, I'd have a -1.5. So that would give me negative. Again, this is always going to be positive. This would still be negative, and this would still be negative. So overall, this is negative. And here I can pick a 0. So that is going to give me a negative, positive, negative, positive. So overall, that is positive. Here I can pick 2.5, so it's going to give me negative, positive, positive, positive. So overall it is negative. And for 4, it's going to give me positive, 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 positive. And that's what's happening with my graph there. So I'm going to graph my asymptotes. And I've got x equals -1. And x equals 2. And then my slant asymptote started a y-intercept of 2. My slope is 1. Looks something like this. Okay. So there are my asymptotes. Now, I know y'all don't always listen to me when I say this, but I want you to do this like for real this time. If you don't already have this graph, I want you to pause this video. And then I want you to get as much of this graph on here as you can, and then come back and finish it. Okay, but try to get this graph on your own first. See what you can do. So pause. And now if you haven't really paused, you really need to pause. Okay? Then you can start back up. All right. So here's what I'm going to do. I'm going to plot the points that I have, which are first my roots. So I have one here at -2, one at 3, 1, 2, 3, and then I have one at 0. Well, those are where our roots are, but then I also have a point at 0, positive 6. So 2, 4, 6, 2, 4, 6. Right, so there are my points. So I actually have a point in each section of the graph, and I know what's the whole positive, negative thing going on here. So like, for instance, if I start from the right, I know from positive infinity all the way to 3 here, it is positive. So it's probably coming down like this. And then it's from 3 to 2, it's going to be negative. So I'm pretty confident that this looks something like this over here. Oh, I knew I was going to miss. I'm going to start from here, I guess. Something like that. Okay. So in between these two then, this is the only point I have. Now I have some tangency, but I don't have any togetherness. So if this is coming down here, this is coming up here. Remember, I'm not guaranteed of that just because of this slant asymptote, because we've already had some that, really intersected it. But I do know that between -1 and 2, it's positive. So the only way it can be positive the whole time is if it does look something like this. And again, since I don't have any togetherness, I know I have to be starting at negative infinity here. Plus, I know from this, from -2 to, from -2 to -1 is supposed to be negative. So in here, I am negative. So I know it's going to have to come up like, oh, goodness. Like that. Okay. Now here's the tricky part. Is that I have tangency at -2, which means it's going to bounce. Plus, I know it stays negative over here, right? That's what's happening here is with this bounce. So I come up and I hit that, and I'm going to come back down. But I've got this slant asymptote here. Which side of it does it go on? And if you didn't think it could intersect it before, this point right here is right on that asymptote. So I already know it intersects it. So what I'm interested in now is, does it go on the top or the bottom? Like, does it come, if it comes back down, then it's probably going to have to do something weird underneath here, like some weird curve that I'm not sure about. or it could come this way and hug it on this side. So if we want to decide that, I'm going to pick a point, see what happens. Now since I've got to square some stuff, I don't want my numbers to get too big, let's just see what's happening here at -3. Okay, so I'm just going to pick -3 for my x value. As I said before on that one that we worked in class, that I wouldn't have necessarily expected you to know that it crossed the asymptote. You'd have to do some guessing and checking there, which I wouldn't expect of you. But here, you know it's crossing it. So you're going to figure out what the heck is happening with it after it crosses it. And so if I take my -3 and I plug it in, and I'm going to plug it into the factored form. I think that makes a little bit more sense to me. So this is going to be a -3 minus 3 times -3 plus 2 squared over -3 minus 2 times -3 plus 1. Right? So -3 minus 3 is going to give me a -6. This becomes a -1 squared, which is really just 1. And then this gives me a -5 times a -2. So that's going to give me -6 over 10, which is a -3/5. Okay, so let's just think about what that means. I know the slope of my line here is 1. Right here, the line crosses the x-axis. So clearly, this right here, it actually crosses at -1, even though my line looks thick. But the function at -3 only goes to -3/5. So it's on top of the line. So that right there tells me that it's not coming back down underneath like this. It's coming back around here and hugging the line like this. And I could, I could look at my -3/5 or whatever. I don't have to necessarily even hit that point. I was just giving me an idea of what's happening. And it comes back down and hugs the asymptote there. So it looks something like that. But again, a whole lot better. And when you graph these on the calculator that I know some of you are using, it doesn't show you the asymptotes. But if you did everything you're supposed to do and you get this crazy looking graph, you can graph this line. You know what this line is. You just found it. It's right here. You know what that is. You can graph that line so you can see what's happening with the asymptotes. You can't graph the vertical lines depending on which calculator you're using, but those I think you can kind of understand and figure out. But you can graph the horizontal ones. You can literally graph them in the slant ones so that you can see what's happening with the function.